Hello, welcome everybody to this month's Blatchford Product Showcase. My name is Mike Magee. I'm the Global Education Manager for Blatchford, and I just want to start by saying thanks for being on. I know everybody is so busy beginning of the year, and taking an hour out of your day to listen to us talk about the Tectus. We really appreciate you being on during this time and doing that for us. So, thank you. Without further ado, I see people are joining. So while they are joining, we're going to go through. Let's see. Let me get the slide going here. We're going to first say who we are. Again, my name is Mike Magee. You can see my QR code there. That is my QR code for my information. If you would like to reach out to me, the easiest way, of course, is just emailing me at mike.magee@blatchfordus.com. But you can also just scan the QR code there, and that will give you my information. So scan that, and when you do that, it will also give you the opportunity to share your contact information back to me, and I can save your contact in my phone. That way, I can know who's calling when you call me with a question. And the slide keeps advancing, so my apologies. We've also got David Telford on the line. So, David, if you want to introduce yourself, I keep pointing over here because we are coincidentally in the same room, which is unusual. We're usually in different parts of the country.
So my name's Dave Telford, and I'm one of the clinical specialists with Blatchford. I've been with the company about 5 years, practice orthotics, prosthetics for quite some time. So really excited that you all are on the webinar today, and we have a chance to discuss the advantages of the Tectus for your patients.
Yeah, and just to reiterate, this is who I was. I didn't say that, but as a global education manager, I've been with Blatchford for about 13 years now. So again, what we're going to be doing today is talking about the Tectus. Everybody is on mute, and that just makes it a little bit easier. There's not as many dogs barking in the background and that kind of stuff. The webinar is being recorded, so you can find this webinar and all of our past webinars on our YouTube channel. That's Blatchford Institute channel. You can go through that and look at the all of our past webinars. And if you miss a part of this one, you can always go back and watch it. It should be posted by tomorrow. If you have any questions, please use the Q&A panel. As I said earlier, David and I are in the same room, so I'll be monitoring the QA panel for any kind of questions. So please type those away, and I will answer those as they come up. Again, any questions, you can reach out to me at mike.magee@blatchfordus.com. There will be a quiz at the end. I'll send the quiz link out after the webinar, but there will also be a QR code on the last slide that you can use to take the quiz right away if you don't want to wait on my email. So without further ado, we'll go ahead and get going, and I'm going to let Dev take over and talk about the bulk of the Tectus, and I'll chime back in towards the end. So again, thanks for joining, and let's get going.
All right, thanks, Mike. So this is the Tectus, embracing the next step. So we're going to go, and what is the Tectus? So the Tectus is a slim, lightweight microprocessor controlled KFO. So it has technology that allows your patients more mobility, a more natural gait pattern, and lets them get back to life if they have physical challenges. So we call this our performance response technology. Basically, what we did is we took our technology that we have in our prosthetic departments or products, and then we applied that to our orthotic system here. And as a person who spent a lot of their career in orthotics early on, it is really exciting to see this technology coming to the orthotic field and just having more options for clinicians in treating the patients that you work with every day.
Yeah, and just real quick there, Dave, the going back to the technology and the prosthetic technology. So we've been in business since 1890, so we've been around for a very long time, and we've done a lot of really important prosthetic advancements. I won't go into all those; they're on our website, but some of that is our microprocessor technology, and what we've done is taken some of those sensors and moved them over, as you were saying. So it's all based off of our prosthetic knowledge, especially the Elan, which we know is such a widely used microprocessor ankle.
Yeah, thanks. So here's just some of the general features of the Tectus, and we're going to go into more detail as we proceed through the webinar. So as we said, it's a microprocessor controlled KFO. We have a spring assist, a mechanical spring in the device that helps your patients extend their lower portion of their limb. You have independent hydraulic adjustments for sitting and for being able to navigate stairs. And the device is small and compact. It's 40% smaller than competition. And because of that and the unique design, the battery pack is separate from the actuator. You can accommodate unique limb shapes with this device. There are 5 different modes. There's a walking mode, sitting mode, stairs. You have a lock mode that your patient can be fully secure in, and it has a free mode. And your patient is going to go between modes either via the buttons on the actuator. You can see there with the LCD display, or they can use a fob. And really your patient's going to figure it out what is best for them and how to go between these different modes. So it is some unique technology with this. You have a clinician app that allows you to program the device. You have a section in that is called a gait visualizer that allows you to take videos of your patient if they allow. Clearly, the information is the patient's, and you have to be able to get that authorization from them, but it allows you to just take that next step in clinical evaluations. So we're excited about the future of that. And as we move forward here, so this is just a display of what the gait visualizer looks like. So you can video and you can look at the data and syncs it up. So here's this video, let's watch that.
So this is pretty exciting stuff. This is something that's not in the industry at the moment. What it is, as Dave said, you no longer have to go off of your intuition and your thought. You can actually use data to prove what you're seeing. You can also use it to prove there's a problem with the device, or a patient's not able to do something, perhaps because they've gotten better than they were when they first got the device. Maybe they're taking longer steps now. You can use this as a way to be able to see inside the device, if you will, to find out what the sensors are doing in real time with that actual step. So it's pretty phenomenal stuff, and we're excited to see where this is going in the future as we develop products.
So who is the candidate for the Tectus? So we're going to go into the detail of the selection process. So you can see on your screen, in your upper right-hand corner is the Tectus selection or candidate selection tool that allows you to work through the parameters of the device. And just to go into a little bit detail about that, one requirement is a hip flexor muscle strength of greater than 2 on the Oxford scale. And we also say your patient might have a little bit less than a grade 2 as long as they can use compensatory motion to advance their affected limb past their sound side. So at this time, it's only a unilateral device. You cannot have a patient in bilateral Tectus at this time. Your patient needs to be able to stand independently. That's important for the calibration of the device and for the start point of the different activities and the modes that we're going to talk about. They need to have less than a combined 10-degree contracture at the hip and knee. It's for those folks that have flaccid paralysis of the lower limb, insufficient knee control. It can be for stroke patients who have mild tone, as long as that tone does not inhibit them from moving through the range of motion with their affected limb. Your post-polio patients, and then individuals that weigh less than 220 pounds. So what are some of the contraindications? So it'd be for those people that could not initiate hip flexion through swing phase with a fixed deformity or a fixed flexion contracture of more than 10 degrees at the hip and knee combined, fixed valgus and varus deformities at the knee of greater than 10 degrees. They may have more than that in standing, but if you cannot correct that deformity to 10 degrees or less, then that rules them out for this device. If somebody has a leg length discrepancy of more than 15 centimeters, which is 6 inches, so it will accommodate a significant leg length discrepancy. If that person just doesn't have sufficient manual dexterity to move between modes, again, they have the option of the buttons on the actuator or with the fob, or if they have poor cognitive function, they just can't get the concept, then they are not a candidate for this device. So you can see there is a very significant patient population that this will work for. So how does this work, or what's happening through the gait cycle? If you look at this screen, the orange and red line through the center, right below the person walking, that's what the Tectus is doing and the work that it's doing through the gait cycle. So you can see at initial heel contact, you have resistance to flexion, stance resistance. Through the loading response, it's going to provide stance resistance. Mid-stance, it's still continuing to give that support. And then at terminal stance, it starts doing its magic. There is an IMU in the unit. And once the thigh angle gets to a -8 degrees, it goes into forward walk and it allows the knee joint to release. And your patient then, through the spring, it has controlled heel rise at pre-swing and then coming forward initial swinging. And one thing to point out, that once the unit gets back to 0, it releases at -8. Once the unit gets back to 0, then that stance resistance is reinstated. So it provides a stumble recovery for your patients, which is a nice safety feature for this device. Then they come forward, they land, get to terminal stance, and they're going to have resistance to flexion so they can safely take that next step in the gait cycle. So let's go into a little bit more detail about the different functions of the Tectus. So I said before, we have a walking mode, sitting mode, stairs, locked, and free. And you can see those images there on the actuator. So your patient is going to get a visual reminder of what mode they're in when they change modes. It comes up and it stays on that screen for about 5 seconds. They also will get a vibration from the device to know that they've changed modes. And again, they can change modes via the buttons. And your upper right-hand picture there is the bottom. That's the button that is red and green. That's your power button. The button above that is the B, and the most proximal button is your A button. So they can change modes using a combination of those A, B buttons, pressing those, or they can use the fob that's there on your left, and they can select different modes that way. And really, your patient is going to determine what works best for them. We have some patients that exclusively use the fob. We have other patients that almost exclusively use the buttons on the actual unit itself. So forward walk. There are actually 3 sub-modes of the walk mode, I should say, not forward walk. There is the forward walk, and I talked about that a little bit in the function of the device. So when the patient takes a step forward with their sound side, they're going to get a negative thigh angle with the affected limb. Once that reaches 8 degrees, -8 degrees, it's going to release and go into forward walk. When your patient is standing stationary, it's in standing support. So they can comfortably and with confidence stand and know that they're going to be supported. And if your patient were to step backwards, it goes into back step and the unit will stay locked so they can safely take a step back. Sitting mode. There are 3 modes in sitting, or substates, if you will. So the patient, as we discussed earlier, you're going to be able to dial in their sitting resistance specifically to your patients. That's usually a really neat time in the evaluation process. And a lot of these folks that are using this device, this is the first time that they've had resistance into sitting. And it really is a neat thing to watch and something they really enjoy. The fact that they don't just plop down into a chair, or they don't have to rely exclusively on their sound side. They can safely sit with that sitting resistance. And once your patient gets to a seated position, the motor is going to relax after about 2 seconds so they can position their foot in a comfortable place while they're sitting at their desk or in the living room. They can just move their foot into a comfortable position. And then it has a sit to stand feature. So if your patient sits in the sit mode, they're sitting there and they want to get up. Well, if they come up and the thigh gets to about a 45-degree angle and they don't get all the way up into the standing position, it's going to ratchet, or it's going to give them support so they can catch themselves and go the rest of the way up. And let me, one thing I need to let you know. So if your patient's in the walk mode, they want to sit down, they do have to put it in the sitting mode. And you can see that LCD diagram that they're going to get there when they do that, and they can sit down. Again, they have resistance into sitting. It relaxes after they've been there for about 2 seconds. They can position their foot comfortably. And then it has that safety feature of going from sit to stand. What is nice is that when the patient goes from a sit position to standing, it automatically goes into walk mode. So here is a video demonstrating what I talked about. You can see patients puts it in sit mode, doesn't take long. They ride the hydraulics into the chair, and it's a really smooth process. Here, Alex puts it into sit mode. So really, it's very quick, and it's a nice feature that your patient has. And again, when they go from the sitting to standing, it automatically goes into walk mode. This is a video showing the stair mode. So your patient can descend stairs 2 ways. They can use it in a fully locked position like their traditional KFOs, or your patient, once they come to a set of stairs, they simply reach down, place it in stair mode, and then they can ride the device step over step safely downstairs.
And the beauty of that is it will stay in stairs mode until they stop and press the walk mode. So you don't, the user doesn't have to worry about, is it going to be in walk mode? Is it going to yield? Is it going to be stiff? What's going to happen on this next step? Because it's consistent. The user knows it's in down ramp mode or downstairs mode.
And you can see there, Alex, he reaches the bottom of the stairs, puts it quickly back into walk mode, and he's off and going. So again, you can do that via the fob or with the buttons on the device. So if there is a lock mode, say your patient is going to be stationary for a while and they're wanting to do an activity, maybe at a workbench, at the sink, they can put it into lock mode. They get the LCD reminder that they are safe and stable in this position. Again, it stays in this lock mode until they take it out. So again, a lot of safety features in this device, really freeing up your patients to live life more functional, if you will. It's just an opportunity for them to be able to do more. Stumble control, we talked about this a little bit earlier, that once the patient starts bringing their foot forward and the unit gets to a neutral position or that 0 mark, that stance flexion is reinstated. And if they do catch their toe or they stumble, there's an opportunity for them to catch themselves and prevent a fall. We talked a little bit about the spring, the mechanical spring that is in the device. And you can see here the patient's walking, and because of that spring, your patients can change their walking speed and the device stays up with them. So maybe initially they need a little bit more spring assist. They get used to the motions that are required to advance the limb, and you can turn that spring assist down. But because that spring is there, we do have the ability to accommodate changes in gait speed. This video will demonstrate how to adjust that spring. As I said, it's mechanical spring. You can open the top of the device. Our orthotist there is using a 5mm wrench, and she is going to turn this clockwise to preload the spring to give it more assist. If the patient requires, you can actually change springs. Each unit comes with 3 different stiffnesses of spring. And if your patient doesn't need quite so much assistance, we can put in a less stiff spring for your patient. So again, it really is very tunable for your patients. You can dial it in for specifically what your patient needs. Just some of the specs on the device. It's for activity 1, 2, 3, and 4 patients. Said earlier, the max weight at this time is 220 pounds. The component weights of the Tectus is 660 grams. We use a Nikon rechargeable battery. It takes about 2 hours to fully charge the device. That's from a completely discharged battery. And your user is going to get about 18 hours of continuous use. So easily a day's worth of use with the charge. It is comes with a 36-month warranty, and it's IP54 rated. So if your patients get caught in a rainstorm, they're going to be okay. It'll hold up. It is PDAC approved. The code for the Tectus is the L2006. So that's a recognized code, and that's the one code that you use for this orthosis. So I want to show you a couple of patient case studies just so you can see this device in action and just the benefit that the patient has. First patient is Alex. He was in the British military and suffered injury from an IED, but he had chronic sciatic pain, hip dysfunction, lower back pain, and he originally wore a lock knee KFO and then eventually got into the Tectus. And he was really interested in the device in that it would allow him to go downstairs step over step. So that was important to him. You can see here, Alex is walking without any orthosis, really unable to advance his affected limb. And here you can see him from the side. So that's how Alex walked prior to the Tectus. And here he is with the orthosis. Just a remarkable difference. He does have a little bit of vaulting, and you can see in this video, but that's due to the fact that he had a little bit weak hip flexors. So he's recruiting his core, doing a little bit of vaulting to be able to advance his affected limb past the sound side. Happy to report since this video, he has regained some hip flexion strength. So he is able to use this device quite effectively. So here is Alex coming down the stairs. This is his locked KFO. He did have some significant back pain when he would use his locked KFO, just because it's an abnormal gait pattern. But with the Tectus, he has flexion during swing. And you can see here, he's coming down the stairs, step over step, and then switching into walk mode and carrying on. Our next patient is Alfie. Alfie had a knee injury, ruptured Achilles tendon, multiple orthopedic interventions, and just unsuccessful outcomes. She likes the Tectus because she said it just allows her to get back to doing things she did when she was able-bodied and getting on with life. So here is Alfie prior to her Tectus. You can see she has a little bit of tone in that lower extremity, was not so much that we could not use the Tectus. And when she is in her KFO, we're able to control that quinal varus that she's demonstrating there. So here she is with her Tectus device. And it's, again, a pretty remarkable difference with it. And she's able to just get around. One of the things she said, she's able to go shopping on her own now, which was a big thing for her.
She's got a remarkable video on our website that it's a bit of a tearjerker when you watch it. You can really see the effect that these devices have on somebody's life and how it can give them a reset, if you will, and be able to do their normal activities again.
Oh, absolutely. So our third case study today is Mick. This gentleman had a stroke, which affected his ability to advance his affected limb. He had lower limb weakness. He said it's just given him confidence back to get out there and to do things again. And we're going to show his video here without the devices on the left and with his orthosis is on the right. You can see he walks with significant hyperextension in that affected limb, difficult to advance and then just really ambulate safely. And here he is with his Tectus, able to control that hyperextension. He's getting a nice flexion through swing phase, good ground acceptance. He uses his fob to change modes, and it just really made a huge difference for him.
You can see he had that left arm amputation, and that's due to neurological pain that happened after his stroke. So anytime anything touched his arm, it was super painful. So he had an elective arm amputation. So that key fob is really helpful for him because he can use his right hand to be able to use that and not have to reach over to touch the buttons to be able to change modes. And you can see he just keeps it around his neck on a lanyard.
Mm-hmm. Then our final case study is the gentleman, John, post-polio, had significant weakness in his lower extremity, zero muscle power at the knee and ankle, 3 at the hip flexors. And you can see here, he's walking with the orthosis on the left. We were able to accommodate a leg length discrepancy with him, with the shoe. And we did accommodate a fixed varus deformity at the ankle in the orthosis. So again, just I think he'd had it on for about 5 minutes with that video on the right. It just allows him to continue to move about society. And
yeah, I'm going to elaborate a little bit also. If you go back to the you don't have to go back. It's several slides. The gait pattern or the gait cycle. One of the patients that we're seeing some success with is in the post-polio patients, and one reason for that is that initial contact, as Dave said, it is stiff at initial contact. There is very little to no knee flexion that occurs at heel strike. So, as you know, post-polio patients tend to be very particular about how their brace fits and how it feels. And if there's any motion at the knee, then that can be perceived as a failure or as a potential fall. So any kind of motion there, and that's where the Tectus really shines, is being able to have that rigidity, especially at heel strike and carrying on through mid stance without having any knee flexion or the possibility of knee flexion. There's no way for it to yield in that phase. So that particular patient profile is really seeing some success in that. Or anybody that is got such weakness that and history with it to know that a flexion moment or a yielding moment is considered a fall risk. So that's where we're seeing some really big success. And you can see that with John here.
Mm-hmm. Exactly. We do have a document guide or documentation guide that our territory managers can get to you, or you can reach out to Mike or I, and we can provide you this information. We have a reference for documentation for your physicians. This gives them an idea of what documentation is ideal to get their patients in this technology. And as we all know, this documentation is critically important. We want to help you in that endeavor the best that we can, and that's why we have this document guide. So what is the process for you to have a Tectus for your patients? Well, first, there's going to be the assessment. You would have the Tectus candidate selection tool. You can communicate with the Blatchford clinical team or your territory manager, and we're going to assess and see if your patient is a candidate. You may want to get authorization, and then we're going to come in and teach a certification course. And what that entails is a more detailed slideshow than what we're having today. We talk in more depth about the different modes, just what is behind the device, why we want certain parameters, and the function of the device to give you good information on that. We require a patient for this, so we're going to have a Tectus evaluation brace to make sure that the patient can achieve proof of concept with the evaluation device. And then we're going to cast the patient together. We're going to go through the casting process. It's a little bit different than just your standard KFO casting. And then at that point, we're going to send that mold off for a check device. Every Tectus is going to have a check device because this is an advanced system. We want everything to fit and operate just perfectly. And that's what the check device is for. And then once we determine that's fitting and it's working well, we're going to move on to the delivery phase. And again, we're going to be with you as Blatchford clinicians, giving you good support through the whole process. We recommend gait training and physiotherapy. In fact, we have a physiotherapy recommendations or suggested exercises. I'm sure most of you all have a favorite therapy group that you work with. We will provide this to you to give to them. And that's just a good resource for your therapy groups that you work with. And we're going to support you after the delivery of the device. So I know Blatchford has a good history of working with you as you're supporting your clinical practice, and that it's nothing different about that Blatchford support with the Tectus. We're here to help you help your patients achieve the best functional outcome they can have. So here is a look at the Tectus evaluation brace. We call it the TEB. It looks large because it is large, but the good news is it's a one size fits all your patients. And again, it is a very effective tool to allow us to determine your patient can meet the requirements to use the device. So here's a video of a patient that is trialing the Tectus evaluation brace. It's put on her, and again, she can move and walk, and she's showing that she can achieve the appropriate thigh angles to get it to release properly. Here she is riding the resistance into the chair. So again, it just allows you to make sure that your patient is truly a candidate for the Tectus. So the casting technique, we'll go into this a little bit. We recommend a two-stage cast, and you get a casting checklist with your information regarding the Tectus. It walks you through this process. We cast with a 10-degree anterior shank angle. You can see that it's being measured there. Again, you have that checklist. You do the AFO section and foot section first with a heel wedge to accommodate the heel height of your patient's shoe. You get your AFO section done well, and then you go ahead and cast the thigh section. You can do that standing if your patient's able. You can do it in a lying position. We just recommend that you have help so you don't deform the thigh section of the cast. It's critically important that you take a good mold because, as we all know as clinicians, the better you do the early steps, the better your outcome's going to be. And this is an advanced system. It's not difficult, but it is advanced, and you just have to pay attention to your clinical technique to make sure that your patients are going to get the best outcome. This is a picture of the check device. So it's a solid piece of plastic. And with this device, you'll place it on your patient. You're going to check your internal fits, total contact. You're going to mark your trim lines or trim your trim lines to the appropriate levels. You're going to check your joint alignment. And in this process, what you're going to do is you're going to have the patient stand on the same heel height that you casted the patient with originally. You're going to make sure that it's fitting well and that everything is aligning appropriately. You're going to check your mechanical joint placements compared to your anatomical joint, and just do a thorough evaluation of the check device, because once we get to a final device, it is a very rigid system.
Just real quick, we did get a question about what is the minimum, go back one slide, please.
Sure.
What is the minimum height for that you can use the Tectus for? And I'm not sure if you have a better answer than this, but what I usually think of is you basically have to have enough room to fit the components. And because our battery module is, we can move it around wherever you need to. You can have it on the anterior thigh, you can have it different places. It allows us to be able to use a slightly shorter stature individual. But you do have to have enough room for the ankle joint, of course, and then an upright that goes up into the knee joint. And then again, we can move the battery pack around and make it a little bit easier. So I don't know if we have a recommended minimum height, do we?
So we do. The recommended minimal height for the evaluation brace is 26 inches on the inseam, if you will. But if somebody is a little bit shorter than that, if the TEB, when you fit the TEB, the patient is going to wear a shoe on top of the device. So if they're, let me see if I can get to that real quick. You can see here on the left-hand picture, the patient has their shoe on. So if they're a little bit shorter than that 26 inches, we can put a lift inside of the trial device and get them to that point. But that's the minimum device. And as Mike said, you can see there on the left, you do have to have room for the joint and the actuator unit on the lateral thigh. We can move the position of the battery to accommodate different thigh lengths or sizes.
And Brett had a good question also about, he mentioned the module looks like it's sticking out a little bit far on the lateral aspect. And that's really based on the patient's anatomy. So it depends on who the patient is, who it's being fit on. So if you want to hit on that a little bit, and
sure,
touch on that.
So the actuator and the joint have to be vertical. And if, let's say, your patient has a little bit of a valgus deformity, it still has to be vertical. And if the thigh is, as it progresses proximally, is coming out or wider, we're going to have to move that joint away to allow the actuator and the joint to stay in a vertical position. But
so it's totally patient dependent. And if you watch the videos of Alex, his isn't sticking out nearly as far as, say, Alfie's. So if you look on that picture, it's not nearly as far as the other one.
So this shows the finished product. It's a laminated device. And so it's a rigid KFO system. The rigidity in the device allows the energy that the patient is using to move forward to be translated appropriately to the joints and gives them a maximum functional level. That's why we require the check device. This is a rigid system. It's difficult to make adjustments to it once it's finished. You still can add padding inside the AFO like we do with other orthotic devices, but you are limited on how many adjustments you can make. So you can see we do have follower joints. We have a medial knee joint and a medial ankle joint. Again, that's just to keep everything in alignment and give it structural integrity. And there's a nice checklist or inspection list that comes with the finished device. And again, your clinical, Blatchford clinical support will be there for the delivery, and we'll go over the programming. We didn't talk about that much earlier, but we'll be there for the programming and fitting of the device. So some common questions. Why do we use a remote control? Well, that just gives your patient an option for changing devices. It's, You can see the fob there. You can see the different modes that they use. And your patient has the confidence that once they're in a mode, they stay in that mode until they take themselves out of it. So again, it's a nice safety feature for your patients and just to give them confidence to tackle life. Let's see. Why do we have to change modes for stairs and sitting? Well, we talked about it a little bit earlier in that each of those functions have their own resistance level. So you can dial that resistance in for your patients. They may have a very specific way they want to sit, and you can give them that resistance. And then they're going to need more support when they're going downstairs, step over step. So because of that, we have separate settings on the orthosis for those two activities.
So let me hit the summary here and answer a couple of questions while I'm at it. One question was first off, a bilateral. Thanks, Richard, for the question. Yes, right now we are not able to fit a bilateral patient, and that has to do with the programming. If you think about the way the thigh angle works, and if one is going to a negative thigh angle to get it to go and release into swing phase, and the other one's in a positive thigh angle and moving in the wrong direction. So it's just a programming sequence, and they're working on adjusting that and making it to where down the road we'll be able to fit bilaterals. But at this point, it is unilateral, and it's a concept of it's probably not a great phrase, but you got to walk before you can run. You got to be able to do what you do really well before we can advance into the next little bit bigger hurdles to cover, if you will. Any different functionality from the other orthotic device in this space? Thank you, Jonathan, for the question. Well, there's a few. First off, we'll talk about the spring assist right there. That is something that is unique to our device. It's the only device that has a spring extension assist. So if you've got somebody with a little bit weaker musculature, we can allow a greater knee extension because we can fine tune that extension assist and be able to provide exactly what the patient needs. Again, that is adjustable, of different springs you can put in there. We can really fine tune that. We have our independent hydraulic adjustments. So we have a different resistance for hydraulic stance, hydraulic swing. Hydraulic swing, but hydraulic stance, hydraulic sitting, and stairs. So we can fine tune each one of those for that specific patient, what they need. Somebody needs more resistance going downstairs, we can do that. A little bit less to sit down into a chair or vice versa, we can do that. We also, something else that is a little bit different, and I hit on that because it's something I'm seeing a lot of, is the ability to be in full stance support with no motion, no yielding at heel strike. Some of these patients, that's a critical aspect. And so being able to do that is a little bit unique in our device as well. So those are three of the main, and of course it's a little bit smaller and more compact. Being able to move the battery around wherever we need to adapt to different types of patients' anatomy. Those are some of the key differentiators. But again, what I would recommend is if you're thinking about it, let us come in with an evaluation brace, and we can fit it on the patient, and we can let them have as Dave put it, a proof of concept, and make sure that it's able to provide the functionality that the patient's looking for. So there's been several questions pop up while I was answering that one. Oh, it was a thanks. You're welcome, Richard. Can you discuss the characteristics, I'll let Dave answer this, the characteristics of the lateral ankle joint and also its relationship to the function of the knee joint module?
So the lateral knee joint, it's a multifunctional joint. And what that allows us to do is to, with clarity, give your patient plantar flexion range of motion and dorsiflexion range of motion. So as they are walking level ground or even in some inclines or declines, the ankle is going to allow them to come out at heel strike and then meet the ground. It's going to plantar flex, give them stability, and just allow them to navigate a different terrain. We have one patient that uses the device, and we were walking in the parking lot. We got on grass and started walking. And I said, well, how do you walk on grass now? And she says, I don't. So with the ankle motion and combination of the knee unit, it just gives your patients the safety and security to emulate on different terrain.
We've got a couple questions about the lifespan. It is a 3-year warranty on the device itself. The carbon fiber was another question. That's a little bit different. So, but again, that's the cheaper one of the two, right? So you may have, if we need to do something different with the KFO itself, that can be done. But the module itself is a 3-year warranty. I don't know if you have anything to add to that.
Yeah, and it is a wet lamination or a pre-preg lamination, but it is a very rigid system. Again, just to give it integrity and allow the maximum function of the knee joints.
And it is pre-preg or wetland, but we do that in-house and primarily pre-preg, but we can let some under some strict guidance some wetland. So there is a little bit of wiggle room there, but it is done in-house. So we do the fabrication for Tectus. Can different ankle joints be used in dynamic carbon? So Fred, thanks for the question. I appreciate you being on these webinars. We do recommend the triple action joint at this point. You can do other joints, but we really recommend the triple action. We love the way that thing functions, the way you can adjust it while it's still on a patient. The way it performs with the boosters and all that kind of stuff. It does a phenomenal job. So we really like that. As far as a dynamic carbon, I'm thinking maybe you mean like a posterior leaf spring type layup or setup. Right now, we're not recommending that. We are, again, the whole concept of start, because it's a relatively newer device. We want to make sure that we're doing everything consistently, and then maybe we'll branch out over that. We're not quite ready to branch out. That could be coming, so stay tuned. But for now, we are looking for just double ankle joints, a follower joint, and like I said, we recommend a triple action joint. Let's see. I think I've covered all those questions. The cost, John, great question. I'd reach out to your territory manager. They'll be able to help you with the cost for Tectus. Any limitations on weather or temperature, severe cold, battery life, extreme heat? Well, extreme cold. I mean, we are in Texas and there's an extreme cold. Everybody up north is laughing at us because it's 20 degrees and our kids are out of school for 2 days. But it's not to be taken lightly. The cold weather is dangerous. But there are some different weather restrictions in our IFU. But it's not anything we've had a problem with. We haven't seen any. We've fit them in Phoenix. We fit them in Minnesota. We fit them in some really cold areas and some really warm areas, and haven't seen any of the issues pop up that you might be concerned about. I don't know if you have
no, I just the weather will affect the battery life, but not to the point that it's not useful at all. And we've fit a patient in the upper peninsula of Michigan and had no reports of it not functioning. So it will accommodate a wide range of temperatures and
right.
Full confidence.
A list of payers who are authorized. The clear one is Medicare, right? The L2006 L code. That's the obvious one. But I would say consult the different insurances you're looking at. And we do have the documentation guidelines that can help with some of that. If you have somebody you're really struggling with, give us a call. We can help and help ensure that you're going to get coverage prior to going down that path. We've got some people on our team that can help with that. So reach out to us. We'd be happy to help.
And your territory manager is going to be a fantastic resource. They're going to support you through this process, just like your Blatchford clinical team.
So great question, Richard. You asked about the 8 degrees. So part of the 8 degrees, it's not just a -8 degree thigh angle to make it release into swing phase. You've also got to have forward motion. So you've got to be moving in a forward direction for it to release. So that's the big difference. It's not just I'm going to go ahead and advance the slide here also, but it's not just a -8. And if you walk backwards, well, you're in a -8, you're going to release. That's not the case. You've got to have forward motion as well. It's just a little bit easier to say the -8 degree, but there is forward motion that has to happen also. I'm going to advance the slide, and then I'll keep answering questions here. The reason, well, before that, so here's some of the documents that we have. We have a physical therapy guideline on the far left. That's a full booklet you can give to physical therapists. It gives you brief guidelines of what the Tectus can do, how to adjust it, and all that kind of stuff. and then some exercises specific to physical therapy and how to help that with a Tectus. Like I said, we have a reference guided documentation. We have our candidate selection tool, and we have our casting guidelines that can help you. But again, if you've got somebody in mind, we will be there every step of the way. That's our commitment. We want to be there for you while you are going through this process. We know that if you are trying something for the first time, it's a bit of a risk, a bit of a challenge, and we want to make sure that we minimize that challenge by being there to help. So we'll be there for, at minimum, the first two. If you want us there for more, we'll be happy to be there. But our commitment is to be there for the first two that you do, every step of the way. Whether that be the casting, the check socket, if you want it, we could do that virtually if you want to. But the check socket, casting, check socket, and final delivery will be there to support. Here's a programming video just to show the programming sequence. Again, here they're detecting the thigh angle and the hydraulic resistance. Once they hit calibrate, it's going to detect that 0 point, and then it's going to look for that -8 degree thigh angle as they walk. And that's what's going to be releasing it. But here he is walking backwards. You can see he may get a -8 degree thigh angle, but he's not moving forward. So it's going to stay in full stance support. Again, that's calibrating that thigh angle position. Then you can adjust the sitting resistance. Put it in sit mode, and you can increase or decrease the resistance. And again, this is a specific resistance for sitting, not for stairs and not for standing or stumble recovery. It's specific to sitting. That way the patient can know exactly what it's going to feel like when they go to sit.
In the certification course, we go over this in much more detail to give you this step-by-step process. And then obviously at the delivery for the patient, we'll program this together to where you feel confident in doing that.
So we talked about the -8 degree. That's the first step. After that, you can define exactly what thigh angle you want. If they take bigger steps or smaller steps, you can change that. And that's what this stance release angle is. It modifies the subsequent steps thigh angle release requirements. And that's the bulk of the programming. I'm going to go on to the next slide. Like I said, if we want to do a certification, we can be happy to do that. I wanted to go onto this slide so we can answer more questions, but that is the quiz up there. Again, that's our QR codes for our information, or you can just write down our email. But that's our QR code. If you want to add our contact information to your phone, we can do that. Another question. So I think I answered the -8 degree thigh angle and walking backwards. It's not going to go into that if you're not moving forward. So that's the big differentiator there. What are the turnaround times for the test orthosis and the final from the lab? Thanks, Melanie. The final, it takes about 5 weeks probably to get the final, and that's from casting to the check to the definitive. So the whole process is about 5 weeks or so. And it really doesn't, like I said, we do in-house fabrication, and that's in the UK right now. We will be moving to a US partner, but right now it's in the UK. And I heard we're shipping it to the UK every time. That's 2 weeks right there. Well, that's not the case. It takes about 2 days. I needed something from the UK the other day. They shipped it to me on Thursday, and I had it on Monday morning in my home. So, and that's not even going through our corporate office. So, it's very quick shipping over to the UK. So that doesn't really add that many delays to the process. Not nearly as much as you might think. I would have thought it takes a lot, but it really doesn't add that much time into the process. So about 5, maybe 6 weeks total. During test fit, will the certification course be done? So that is the hope. The hope is that we're doing the certification course on a patient of year. We'll come in, we'll do the certification after you've got a patient in mind. So that when we're doing that, we'll do the certification and the evaluation brace, and theoretically the casting at the same time, so that we can do the casting, have it all done in one appointment. Of course, if something goes wrong with the insurance, and we'll hold off on fabricating anything, but that would be the ideal situation, is we're there and we cover it all in one go. So it looks like we're done. I think I've answered all the questions. If I haven't, you've got my information there, or David's information. Make sure you do the quiz. The quiz, I give about a week to complete that. So end of next week, I'll submit these to ABC. So make sure you've completed the quiz, and I will submit the sign-in sheet to ABC. I'll stick around for any last-minute questions. Do you have any last-minute comments?
No, I was just going to say, I appreciate you all taking the time out of your busy day. I know you're busy in your clinics, and just to hear us talk about the Tectus, I appreciate that. And again, as Mike has said a couple of times, if you have any questions, please reach out to your territory managers or reach out directly to us. And we're more than happy to talk about different patients or possibilities with the orthosis. Again, we're here to help and support however we can. And we're just excited about this technology and being able to bring it to our patients. And that's the primary thing.
Thanks, David. We did get a couple quick questions. Is there a specific mode for walking backwards? Thanks, Richard, for the question. No, it's part of walk mode. So there's walk mode. And within walk mode, you have forward walk, which is a -8-degree thigh angle that we've talked several times about. And if you get a positive thigh angle and a backwards motion, then that goes into backwards walk. So you end up at about 16 degrees of kind of postural sway also, where you're in full standing support. So walk mode has those three submodes: a forward walk, standing support, and then the backwards walk. So it's a subsection of walking mode. And is there a sign-in sheet? The sign-in sheet was in the Zoom sign-up list. So I've got that on the back end for people that signed in and then accepted and joined the meeting. John, if you would like to send me an email, I will pass on your email to the person who writes certificates, and we can send you a certificate and you can self-report that as a BOC orthotist. So if anybody is BOC or state licensure or whatever needs a certificate, let me know. We can get that out to you. That's not a problem at all. I will be sending an email, so the easiest thing may be just reply to that email. Let's see. I think I have one more. Quiz question for a sub mode with walking backwards. I'd have to go back and read the quiz, but again, it's a sub mode of walking mode. So it is walk mode, but it's a sub mode. So it's not anything you have to enter, it's automatic. So you have a sub mode of forward walk, a sub mode of backward walk within walking mode. Somebody's doing the quiz while they can still ask questions. I love it. Okay, well, that is I think that's all I've got. Thank you, Richard. That's all I've got. Again, thank you. We do these monthly. We usually do them on Thursdays, so I appreciate the flexibility. I had something on this Thursday where I just cannot get out of that meeting, so I appreciate the flexibility to be here on a Wednesday instead of a Thursday. But we do these every month. It's usually the third Thursday of the month. So we look forward to hopefully joining us next month. And you've got some exciting stuff coming, so stay tuned. Thank you very much for your time.
Thanks.